Hello everyone, today is day 4 of 15 days of code challenge by Harshita ma'am. So today my problem is moving zeros at the end. So from my copy, if I explain the question, that if we have an array, in that array we have to shift all the zeros at the end without sorting it, because if we do it by sort, it will be very easy, but the problem is that without sorting it. And also the problem is that in place we have to do this entire work. We cannot make another array or anything. So first I will going to explain my wrong approach, because wrongs are also needed to be known. So the first approach that I approach the problem is that if we have all the numbers like this and we are told to remove the zeros at the end, that time one thing we can do, like this is I am explaining the first approach that I did, which was wrong, but still know it, that we have all this list and here we are told to move all the zeros at the end. So we can just pick out the zero and shift all the elements at the left, because if we are picking up the zero, then the one place is getting empty, then all the shifting is done, then one position at the end will going to be empty, and then put the zero back there. Like this always doing whenever we are encountering a zero. Is this understandable? And after this approach, that what I have prepared, I tried to code it, and this is what I came up with. But there was an issue. This is wrong, because number one reason, here I didn't handle the logic of the shifting logic. If at the last index, how I am going to get the i+1 index, right? I cannot get. So this place the wrong thing is there. And also one more wrong thing is there, using of the for loop is wrong here. So that thing I have explained in this portion. What I have explained, what are the improvements I can do in this code. Number one is, instead of doing this both this shifting, deleting and shifting, all like that I told, that pick up the element and then shift all the thing at the left, this thing is automatically can done by pop function. So if we are encountering a zero, we can just pop it and automatically all the elements will be shifted to the left. And then we can do append the zero. Append means always it will going to add it at the end of the list. And now the important part is, we are not supposed to use the for loop in this improvement version. Why? Because for loop we know that in each step it follows one each step follows one iteration, right? What happens in I equal to 0? This is the I equal to 0 iteration. This is our initial array. Okay, so first we are encountering a 0. So when you are encountering a 0, we are popping the 0. Then automatically all the elements will be shifted to the left. But in the second iteration, we know the for loop's property is what? In the second iteration, I will be equals to 1. So I is pointing to 1. But see, already the element that is got shifted just now, the 0 element that got shifted just now, because this 0 got popped, and after popping all the elements got shifted. This is all the shifted elements, don't see this now, and then this 0 got appended at the end. So therefore the 0 is at the end. But as per the for loop, I equal to will be 1 for the next iteration. That's why I is here 1. So what is happening, we are kind of skipping the position where shifting takes place. And here in this particular case, see that we have 0 in that position. So this will obviously going to create an error. So that's why for loop is not good here. So we can resolve that issue by using the while loop, because while loop evaluate the full thing without skipping anything. In each iteration it checks all the elements. That's why. And this is the corrected code of that previous wrong version of code. But here is also an issue. The issue is, this is too much taking time. that is big O n square time it is taking. Because why n square? Because of the loop it is taking n times, and because of the pop function it is taking big O n times. Because in the pop function we are not only popping the element, but also shifting the n elements, means all the elements in that position. So that's why. So now the better approach, like we know this approach we cannot work with because it is taking too much time. So the better approach is, it is slightly different than the one we discussed previously. The better approach says that it says that if all the non-zero elements that we have in the array, we keep it at the front of the array, like keeping all the non-zero elements at the front and zeros element at the last. So how we can do this? This is the approach. So what we can do is that we can initialize a variable, whatever name you can give. I have given non-zero index. I have taken it as 0. Okay, initially I have taken it as 0. Then when I am using a for loop over the range of the array, length of array, and checking if the element inside the array is not 0, then what we are doing, we are putting the ith element into the zeroth, means non-zero index position. What is this? See, initially the non-zero index is 0, therefore nums 0 equal to this nums I. Therefore at I position the non-zero element is present, and that will be placed at the first index, that zeroth index, that is the first position of the array. So like this, whenever we are going to encounter each non-zero element, like this we are going to put it in the front, and obviously the non-zero index is getting incremented every time because it has to be filled, right? So this is the thing. But one thing, now how we are fulfilling the zeros? So after we are complete with the non-zero elements, little bit jumble up will be there, but how we can put the zeros is that in the second for loop, if we run from the non-zero index till the length of the array and put the zeros there. Now it is confusing, let's understand from an example. So this is the entire chart that I have created. So this is our initial array 0 0 5 9 2 8. So in the first iteration of the for loop, see this, it is a zeroth element, so the ith element is 0. The non-zero index is initially 0, that's why it is 0. And we are not performing this step, that because it will be only be performed when the element is non-zero. This is as well, when the element is non-zero, then only these two steps will be going to be performed. Then it is the action, like what happened after the change. So in this stage no changes happened. Then at I equal to 1, that is the first iteration, it is again element is 0, that's why 0, and non-zero index is C at 0 because we didn't change anything. So this will be also be nothing now and no change here. But now see, in the second index we know there is a non-zero element, so yeah, it is non-zero element. So till now no change, we are just writing because initially the value was already 0. But here see, at the nums equal to 0, because it was the non-zero index will be here, and this is the I, right, as per the logic we have created. See, this is the logic, non-zero index in short form. So this is what, so what happened is that, see, the second element, that is the 5 element, will go to this zeroth position. So that what it happened, it went to the, not this one, sorry, here it went to the first position. See, the second element got to the first position. Similarly it will happen for the third iteration. In the third iteration also it is a non-zero element, and this is currently the non-zero index is 1 because of the increment that happened here. And then see, also now it is this non-zero index is 1 and ith element is I is 3, right? So 3 means 9. We are going to put 9 in first position, so we put in first position. So again incrementing the non-zero index, like this we are again performing for 4 and 5. The similar thing will going to happen. But now see, after we are done with all the steps of iterations, we are not seeing, we are putting any zeros at the end. Rather see 9 2 is twice, because of this process only we can see what to do. See, we know that our non-zero index is, we got 4. So just check, if we are running a range from this non-zero index to the length of the entire array. What is the length of the array? Length always gives the counting in terms of 1 2 3 4 5 6. 6 is the length of the array. So if we run the range function from 4 to 6, and at those position if we are putting zeros, see, we are getting the exact array. Got it? This is the concept of this part that I have written here in this logic. I hope this is understandable. Thank you.